go ahead and get started. Now again, last time we did 1, 1, 1, 2, and 1, 3. And we've got questions listed to go over from our homework. So we're going to start with 1, 1, and we're going to begin with question 4. 1, 1 is mostly order of operations. So let's see what we have here. On question number 4, we have 9.5 times 16.5 plus 17.6 times 12.8. And I usually use parentheses, but in this case, just so you see it written other ways, these are multiplication dots. So order of operations, what do we do first? We work from left to right. We do parentheses first. Do we have any parentheses? No. Do we have any exponents or square roots? No. So what's next? Multiplication. So now we just go across to multiply. So we have our 9.5, and we'll multiply that by 16.5, and that gives you 156.75. And then we'll do the other one, which is 17.6. Multiply that by your 12.8, and that gives you 225.28. And now we'll add that to the 156.75, combine them together, and that gives us 382.03 for our finished answer. Is everyone okay with that? So we just work from left to right. We start with parentheses. We did not have any inside to simplify down. We did not have any powers. So then we did our multiplication. And then after we did our multiplication, then we went on and we did our addition and subtraction. So that was question 4. Now we're going to look at question 8. Question 8 has a lot of things going on. And question 8 looks more complicated than what it actually is. In mathematics, what we try to do is we try to take something that looks complicated and we try to break it up into smaller parts, simplify it down, and then make it easier to work with. Okay, so what I generally do when I encounter a question like this one, I like to break it up into the top half, which is the numerator, and the bottom half, which is the denominator. So we're going to look at the top half, which is the numerator, first. In mathematics, it's very important to be successful that you're very neat and organized when you work these out. So what I always like to do is split my paper in half when I know there's a problem that requires a lot of work. And so over here, this is going to be my simplified steps. And on the right-hand side, that's going to be all my work. And the right-hand side doesn't necessarily have to be well organized as long as the left-hand side is. So let's look at our numerator. On our numerator, we got 5 times 2 plus 1 minus 6 times 1 plus 1. So order of operations, first thing we do is inside of the parentheses. So 2 plus 1, that's 3, minus 6 times 1 plus 1 is 2. Okay, now we do our multiplication because that's next. So 5 times 3 is 15. 6 times 2 is 12. And now we take 15 minus 12, working from left to right. And 15 minus 12, well, that leaves you then with a 3. So the 3 is going to come down for the numerator, the top half. What about the denominator? Well, the denominator, let me adjust the focus a bit so it's a little bit cleaner. Okay, I'm going to adjust that focus. I think it can be focused just a little bit better. That might be too much. Yeah, that's actually a little bit worse. Just trying to get this focused the best that I can here. I think that's a little bit clear. Yep, a little bit clearer there. Okay, so what about the denominator, the bottom half? Well, for the denominator, or the bottom half of the fraction, we have 5 times 4 minus 2 cubed. We've got to be careful with our order of operations. So what do we do first here? The first thing we do is we do the parentheses first. So 4 minus 2. 4 minus 2, that's a 2. And you can do multiple steps at once, but at the very beginning we're learning things, so I'm going to do them one step at a time. So we did our parentheses first. Now what do we do? Yep, exponents is next, so 2 cubed. If you struggle with how to work out 2 cubed, write it out. 2 cubed is 2 times 2 times 2, which is then 8. A lot of times I think students accidentally multiply, but we're not multiplying here. What are we doing? We are taking it to a power. So write it out. 3 times, that's 8 cubed there. Now, what do we have next here? Okay, so what's our next step going to be? Well, our next step is we're going to multiply. So 5 times 2 is a 10. And then 10 minus 8, well, 10 minus 8 is a 2. So what's your final finished answer here? Your final finished answer is going to be 3 over 2. Leave it as a fraction. You don't have to write it as a decimal. Does everyone see how I did the order of operations there? And just take your time. When you have a complicated question like this one, split it in half. All right. And let's see, does everyone have, make sure, you have a copy of the syllabus, right? Or do you need that?
I need to have it on the app. I don't actually have
it. Oh, yeah, I'll get you one there. Yeah, I thought you were a new student, so let me get you the syllabus and the homework here real quick. Just make sure everyone was here last time. Okay. That's my copy. All right, just so much we have it. Copy syllabus, and there's our homework from last time. All right. And so what we covered again last class period was we went through 1-1, 1-2, and 1-3. So we're going over questions from the homework. And we just did question 8 out of 1-1. Next, we talked about it earlier, but we'll go ahead and talk about question 10 again. Just to make sure we understand what the symbols mean. So for question 10, it says, are these not equal to each other? Now, what does not equal mean? Not equal means they're different. So are these different from each other? Are these fractions different? Yes, because this one won't reduce down on the left at all. And it's not going to match up with the right. So this then would be different. So that would make this then true for question 10. And some of these, it might just be the vocabulary or trying to understand the directions. 11 is next, and then we'll look at 16. Question 11, order of operations. And what we have is we've got 6 cubed plus 9 minus 7. Oh, wait, that's division symbol. Yep, divided by. Sorry about that. That's a division symbol there. So 6 cubed divided by 9 minus 7. So what do we do first? Well, the first thing we do again is we do our exponents. So 6 cubed would be 6 times 6 times 6. And so 6 cubed, I believe, is 216. Right, because it's 6 times 6 times 6. And that's going to be that 216 there. So then that's that piece, 2/16. Now, what do we do next? Right, next we do, working from left to right, we've got division. So 2/16, we're going to take that, that was your 3 cubed, or sorry, 6 cubed. We're going to divide that by 9 now. And that comes out to be 24. So watch your order of operations. Once we've got our division done, then we move on to our subtraction. And 24 minus 7, that gives you then a 17. And I know sometimes it's hard to see those symbols, but that was division, not addition there. Is everyone okay with that so far? And if not, just be sure and say something, and we can look at it in further detail. But make sure you know how I'm coming up with these answers. Question 16. We've got a table. So here's our table. And we need to see what we're looking at here. Now, we've got a table, okay? And it says, for which countries are the values not less than 14.7? Not less than. So that means it can equal 14.7. So if it says not less than, what are we looking for? Okay, the opposite of not less than, right, would be we are looking for things that are going to be what? 14.7 or larger or greater. So which ones would we list out that are bigger than or equal to that 14.7? If I was looking at the ones that are going to be larger than or equal to that 14.7, which ones would they be? Yep, we've got Addison. Okay. We've got Addison. Yep, we've got Branson because that one is equal. Then we've got Cumberland. And then we've got Kendall. Okay, so that's going to be all of them, isn't it? And that's what we're wanting there. So that was just making sure that we understand the wording. And when it says not, that means the opposite. And it says not less than 14.7. So we would be looking for everything that is larger than 14.7 or equal to it. And that is why a Branson is in there, because it equals that 14.7. That now takes care of the questions out of 1-1, unless we have any more. Do we have any more out of 1-1 to look at? Question 3? Sure. Yep. Not a problem at all. Okay, let's look at question 3. And this is a decimal. What are we doing here? We are squaring it out. How many times do we have to write it out? We have to write it out twice. So we'll write these out twice because it's squared. And what does that give you? Later on, I'll show you how to use the caret key in your calculator. But right now, I'm having you write it out twice because I really want you to understand what those exponents mean. When it is an exponent of 2 here, a square, that means we write it out twice. When it's a cubed, we would write it out 3 times. Later on, I'm going to show you how to use the power key in your calculator. But for right now, I want you to just multiply it out so you understand what these exponents really are. So then that comes out to be 0 point, and then we've got 1, 2, 3, 4 zeros, and a 1/6. Yep, you're welcome. Now, one thing I will tell you that I think is very important is I never write it out like this. A lot of times, students will write it out like that. We don't want to write it out like this. We always want to start with the 0 in front. Why? Because if we don't have the 0 in front, it's easy to lose the decimal point. So when I write out a decimal, always begin with the 0, followed by the decimal point. Don't forget that leading zero. Don't write it out like this because you're more likely to make a mistake at the end. Just like we write out dollars and cents. If it's 25 cents, we don't put 0.25, we put the 0.25, right? That's the same way we write these out. So write it out just like it was money. So that now takes care of the questions out of 1-1. And we can now look at 1-2. 1-2, some of these are just understanding the terminology. And on these, we will always want to make sure we read the directions first, because the directions are going to give us clues as to what we're going to be doing. Okay, it says on our directions for question 1, it says, change the word statement to an equation. Now, let's remember about equations versus expressions. This is just terminology. What do we know about an equation? Does an equation have an equal sign? Yes. So when I put this together, I'm going to have an equal sign, right? So that tells me from the directions that I've got to have an equal sign. We don't have to solve it. It just says rewrite it as an equation and then use x as the variable to finish it out. So we've got 6 divided by a number equals 1/6 times that number. So 6 divided by a number. How do we write that out? 6 divided by a number would be 6 over x, right? You can use the division symbol, but normally I use a fraction bar. So that's 6 divided by the number, so that's 6 over x equals, so that's this piece here. What does it equal? 1/6 times the number, so that is 1/6 x. So that's what it should look like. We don't have to solve it yet. That's going to be chapter 2 when we learn how to solve these. Right now, we're just coming up with the equation that matches with that verbal statement there. Question 3. Okay, same thing for question 3. This is going to be an equation. That means we have to have an equal sign. Now, when we read these, is means equal. So when we see is in here, that means that's where the equal bar is going to go. And we have to be careful with the order, too, with subtraction. But wait, that's for 2. For 3, we don't have subtraction. We just got products. Products mean multiply. So for question 3, what we're looking at here is the product of twice a number and 3 is 48. So the product of twice a number and 3. So twice a number, what would that be? Okay, twice a number would be 2x. Okay. And then what are we going to multiply that 2x by? 3. Is means what? Yep, equals. And what does that equal now? 48. I'm going to go ahead and clean these up a bit. I can take that 2 times 3. You don't have to, but 2 times 3 makes it 6. And we can stop there. Because the product of twice a number and 3, which is here. So I put those together, that made that 6x. We don't have to solve it. We will learn how to solve these when we get to chapter 2. Question 5 is next. Now, question 5, we're going to have to check all these possible solutions to find the correct one. We're going to build our equation, and then we're going to see which one of these numbers works. Now, what do we know about these equations? When we've got numbers, only one of them is going to work. So once we find the number that works, we can stop. We don't have to check them all. We only have to find the one number that makes it work. So we're going to write this as an equation, so we will have an equal sign. So question 5 says the sum of a number and 3 is 7. Sum means add, so we're looking at the sum of a number and 3. So sum of a number and 3, that would be what now? Okay, plus 3. Okay, and is means equals again. What does it equal? 7. Now, we've got choices here, and you might be able to just look at it and see which one's going to work. We're going to take a number, we're going to add 3 to it, and it makes it 7. So from these numbers listed here, what number, if I add 3 to it, makes it 7? 4. So what would the answer for this one be? 4, right? Because 4 plus 3 is 7. And that's what we wanted. We wanted it to be the same on each side. So in our case, we got our equation, and our answer would be x equals 4. So I want to see that equation, and also, in this case, x equaling that 4. Question 11. Question 11 has a lot going on again. And for question 11, we're going to break it up into pieces. Question 11, we're going to be plugging values in. So it says on our directions, evaluate the expression for the given values. So we're going to be plugging these in, and we want to round to the nearest tenth if necessary. So we're going to round to the nearest tenth. Now, what does it mean when we say tenth? Tenth is one place. Okay, and it says round, so we can use decimals here if we need to. Make them out to be a whole number, but whenever it says round, that means we are allowed to use the decimals. So let's write up our expression first, and then we'll plug our values in. And we're going to be using x equals 3 in this case, and y equals 2. So we're taking what we've got, and we're going to plug in our new values. So if I plug in my new values, what does that give me now? If I plug them in, that gives me 3 times 2 plus 9 over 11 times 3 minus 2. Now, we can either do this as a fraction as it is, or we can split it up. We can go ahead and just work with it as it is, I think. We'll do parentheses first. So 2 plus 9, that makes it 11. Okay, and down below, we'll do those parentheses. 3 minus 2, that makes it a 1. Now we'll go ahead and do our multiplication. So 3 times 11, that's 33. 11 times 1, that's 11. And 33 divided by 11, well, 33 divided by 11, it comes out to be the whole number 3. Okay, so is everyone all right with how I did that? So that was question 11. 2 more. We've got 13 and 16 to work through as well. Question 13, we're going to be using x as the variable again, and this is also going to be an equation. So question 13 is going to have an equal sign. Now with subtraction, we have to make sure we put them in the correct order. When 5 times a number is subtracted from 7 times a number, the result is 14. So let's make sure we put this in the correct order here. 5 times a number. Okay, so 5 times a number, that is 5x. We are going to subtract that from 7 times a number. So we're taking it away from 7x. So 7x is going to go out in front, and the 5x is behind. Why? Because it says subtracted from. So that 5x is here. We're going to take that away from 7 times a number. So that means that 7 times the number goes out in front. Subtract from it that 5x there. And what does it equal? Is means equals. It equals 14. And we can do one more step. These can go together. And we'll learn more about this later on. 7x minus 5x makes it a 2x. And that equals 14. In the next chapter, we're going to learn how to solve this. You may already know how to do it by dividing, but we'll cover that in detail in the next chapter. So that is question 13. 16 is next, okay, and 16 says mathematical expression. Okay, so an expression, are we going to have an equal sign? No. So we're not going to have an equal sign at all. A number multiplied by 953. So a number is going to be multiplied by 953. So the number is x. And what are we going to multiply it by? Okay, 953. Normally when I write them, I write the number in front of the variable instead of behind. So that would be 953 times the variable x there. And that is what I'm looking for in that one. Did we have any others to talk about in question 1 or in section 1, 2? Anything else? We've got plenty of time. Are those kind of making sense, hopefully? Sure. Yep, we can look at 18. And I know we kind of discussed this a little bit last time. But what is it wanting you to do? It says, determine if the given number is a solution. Now, what does it mean if something's a solution? That means when I plug that value in, the sides are going to be exactly the same. So 3 and 3, 5 and 5, 4 and 4. They have to be the same. So let's look and see if this is a solution. So we're going to look at question 18. And we've got 9x squared plus 3 equals 75. And we're going to use that x equaling 4. So we're going to plug in that 4. And we're going to see if they come out to be the same. So I plugged in that value of 4 there. What do we do first? What's the first thing I should do when I see this question? Okay, parentheses, and there's nothing I can do with the 4, right? So after I've done the parentheses, what's next? Exponents. And 4 squared, remember that's 4 times 4, so that is 16. And now we take that 9 times the 16 there, and 9 times that 16, that's 144 plus 3. And we add that together, and 144 plus 3, that would then make it 147, wouldn't it? So we're going to add 3 to it. And does 147 equal 75? No. So is 4 a solution? No. And that's all I want, is it is not a solution because the sides are not the same. And that was question 18. Sure, and 1, 2. Okay, yep, we can go back and look at 7 as well. And I think we kind of talked about this a little bit last time. Okay, because I wrote on here, so we must have talked about it a little bit in class, but let's go over it again. So what we've got here is we've got this equation. 2x plus y equals 12. and it says the value of x is 4. What would the corresponding value for y be? So what we did was we took our 4 for x and we plugged it in. So that went in for the x there. And then we worked it out because we don't know what y is. We have to find it. So 2 times 4 is an 8. And now we just mentally think about what we've got. Again, next chapter we'll learn how to solve this with subtraction. But in this case, just think about what number is going to make this work. 8 plus some number equals 12. So 8 plus what number gives you 12? 4, right? Because 8 plus 4 gives you 12. So what then does y have to be? 4, right? Because 8 plus 4 gives you 12. Now, when we hit chapter 2, one of the first things we're going to be doing is learning how to solve simple linear equations like this one. And you may or may not already know how to solve them. And if you do, that's great. If not, we'll cover them again in chapter 2 on how to solve that. Question or section 1.3 now. In 1.3, we've got several questions to look at. In 1.3, we're looking at the types of numbers. And we're also going to talk about absolute value bars a bit. And some of these are just problems that make you think. So question 7 is the first one out of 1.3. And we need to find a number that fits this criteria. I want to find a number that is between minus 10 and positive 10. That is a real number, but not an integer. So let's take a moment to remember what real number is. What's a real number? Any number is going to be real, right? So anything that we use is a real number. Now, I want it not to be an integer. There are an infinite number of solutions. All I need is one of them. It has to be between minus 10 to positive 10 and not an integer. So what are integers? Let's talk about integers. What are integers? Okay, so what are some examples? Well, some examples of integers, just so we know what they are, would be things like minus 4, minus 2, 0, 5, 10, 15. Those are all going to be integers. Can fractions or decimals be integers? No. Okay, now, I want to find a number that is between minus 10 and positive 10 that is not one of these. So you could use about anything. 1/2 would work, right? Why would 1/2 work? Is 1/2 between minus 10 and 10? Yes. Is 1/2 an integer? No. So that would work, not an integer. What's another example? Can someone give me another number that's in between there? 3. 3 wouldn't work. Why not? Because 3 is an integer, right? We want something that is not an integer. 1.8 would work. How about pi? Would pi work? Yeah. So as long as it's a fraction or a decimal, and in between minus 10 and 10, any number would work. Why would minus 12.5 not work? If I said 12.5, that is not going to work. Why not? Right? It's not between there. So it has to be between there, not an integer. When I mean not an integer, that means it is either a fraction or a decimal. Okay? It has to be in between there. Does that make sense on that one, though? When it says not, that means the opposite. So we don't want the integer, we want the opposite of an integer, which is a fraction or a decimal. Question 13. how can you rewrite a subtraction of integer problem to make it easier to solve? Well, in some cases, when we look at subtraction, we can get confused by the order and the signs. So in some cases, just simply flipping the order around makes it easier for us to understand. So let's look at one so you can see how we can change the order to make it easier for us to work out. So let's say I give you this. Let's say you're given minus 8 plus 10. Okay, you're given minus 8 plus 10. And I say put those together, combine them. Well, we may struggle with addition and subtraction in that order, but I can switch the order around. So I can rewrite, and we'll learn about the name of the property later today. I can rewrite this as 10 minus 8, right? Because it's easier that way. And 10 minus 8 now we can see is a what? 2. So in some cases, you might get confused by the negative, and you can switch the order around. Just make sure that your 10 stays positive, and the 8 still has the negative. This might look confusing, but we know how to do this, right? 10 minus 8, we know that's 2. So that's what I want you to see, that you can sometimes switch the order around to make it make more sense to you. And that was question 13. And there are a lot of different answers on that one too. You can come up with anything else and see how you'd switch them around to make it easier to actually combine. Question 16. Sure. Uh-huh. Okay. Yes, okay. So let's make sure we know how to do 9. And let's make sure we read the directions here. And these are absolute value bars. So we've got 19. And I know it doesn't always print the easiest, but those are absolute value bars about that negative 23. Now make sure we know what the directions want you to do. Because a lot of times students get confused with this. We want the smaller of the two numbers. So we want the smaller of the two numbers. So what are we actually going to be comparing here? Well, the 19 stays the same, but what about the negative 23? It's inside the absolute value bars, right? And what do absolute value bars do? They make it either come out as a positive number or 0 stays 0. So negative 23 inside the absolute value bars would come out as a 23, and we want the smaller number, so in this case the smaller number would be what? 19. Let's make sure we know how to do 11. 11 is a question. I've given this worksheet out a lot of times. 11 is a question that students sometimes get confused with. We've got minus 17 and minus 15. I want the smaller number. I guarantee that someone is going to say minus 15 is the smaller number. But that is not correct. Why not? We want the number that is further to the left. If I put these on a number line, and here's my 0, here's my negative 15, and here's my negative 17. When I say I want the smaller number, I want the number that is further to the left. So which number is actually smaller? Negative 17. Right? If it helps, you can draw a number line. When you want the smaller number, that is the number further to the left. Now I just put 0 so you'd see that's where it starts at 0. Okay? And I put them in order, right? And we want the one that is smaller, so that means further to the left. So negative 17 would be your answer because that one is further to the left. And I just wanted to pick that one out because a lot of times I've seen students get in a hurry and they'll say negative 15 is the answer. And it's not. I want the smaller number. So we just did 13. We'll now look at 16. Okay, 16 is very, very similar to, I think it was question. Yep, question 7. Little bit different though on what number it has to be. So instead of it being real, this one says rational. So we want a number that is between -6 and +6 that is a rational number, but not an integer. So now we need to make sure we know the difference between a real number and a rational number. So let's make sure we know what rational numbers are. Rational numbers are everything basically except decimals that never stop, some square roots, and special numbers like pi. So these are all going to be rational numbers. 1/2 is a rational number. -3, rational number. 0, rational number. 8, rational number. 1.75, rational number. 4.2 with the bar over it. That means it repeats itself. Still a rational number. What's not rationals? What are irrational numbers? So these numbers are not rational. Okay, these are all rational. So what would something be that's not rational? Okay, square root of 3, not rational, right? Why not? Because it never stops, goes on forever in your calculator as a decimal. 1.84937 ... Okay, goes on forever. So that's also not a rational number. Now, what do we want? We want a number between -6 to +6 that is not an integer, and it has to be rational. So what are some numbers that might work? Okay, 4.5 would work, right? Or -4.5, that's one that would work. What about, here's one that won't work. Why would this one not work? Let's see why this one would not work. How about 3.74562 ... Why would that one not work? Right, because that one is irrational. So it has to be a rational number, which means it could be a fraction or a decimal that either repeats itself or it terminates, and it has to be between -6 and 6 and not an integer. So it has to be a decimal or fraction. And that's just making sure that we understand the terminologies there, what the different numbers are. 19 and 20 are next. So let's look at 19. So 19 says, decide if this is true or if this is false. We've got -11, and that is greater than or equal to. We've got -4, and a minus outside of that. So this is what we've got. Now we need to get rid of our parentheses. And if we look on the right-hand side, what do we know about a negative and a negative here? Okay, there's no space between them. So that means we're going to multiply. And a negative times a negative, well, that makes that now a positive. And we're going to go over this more today when we look at signed numbers. So now we've got this. We've got -11 is greater than or equal to 4. Is this true or is this false? This would be false. Okay, why is it false? When we talk about it and we talk about inequalities, it means it can either equal, so the sides could equal, or the left-hand side is the bigger number because it's opening towards the left, which means the bigger number needs to be on the left. Well, -11 is smaller than what? 4 because it's negative. So that would make that now false. $20, we might just have a confusion about the directions. Question 20 says, use an integer or a rational number to express the number representing change. So we're looking for a positive or a negative number here. And it says the stock market lost 20 points on Monday. So we want to have a sign associated with that. Now we're losing points. We lost 20 points. So that would make it now a what? Negative 20. So all I'm looking for on that one is the negative 20. And that's a signed number because it has the negative in front of it. Okay, does that take care of most of those questions? And we always have plenty of time to work through questions. The goal behind this course is to get you ready for the next course and to get you over some of the testing anxiety that you might have. So we have plenty of time to go through and make sure we understand the basics. Because you're going to be covering more of this in intermediate, but in this course we're just doing the fundamentals. And I know sometimes it might be kind of boring because you may think you know everything, and you may know a lot of it, but this is good review. A lot of it, too, is not getting in a hurry. To be successful in mathematics, you want to take your time. I teach college algebra, I teach intermediate, I teach elementary. The commonly made mistakes are when people get in a hurry. Because they know how to do things, but they'll get in a hurry instead of subtracting, they'll add numbers together. Or instead of multiply, they'll divide. So always take your time. And it gets frustrating if you rush through things and make mistakes. So we're going to go ahead and take a short break, and then we'll come back, and we'll start 1.4. So let's take about a 10-minute break. We'll come back, and we'll look at 1.4. So let's meet back here at 9:05.